So let us start. Good morning. My name is Andrei Laperie. I work at Intel, and with my team in Finland, I'm dealing in Zephyr OS. I'm dealing with the development of communication stacks for that OS. Who of you has anyone heard, anytime heard about these sources? Okay, then I won't give any introduction. I'll just tell you that this paper is a review of our state-of-the-art in the OC and what we're going to do in the next year and a half concerning the functional security and certificate of the certification of the Zephyr in terms of the standards of functional security. Just a few words about Zephyr, an overview. About 4 years ago, Intel decided to create an open-source operating system for small devices, the system that would live where Linux would not be installed. And we started with the following. We opened the microkernel, DX Forks, and we created a project around it. Since Intel knows how to develop software, from the very beginning we decided to do it in such a way so that it wouldn't be associated with any particular corporation. So the project that we created, Zephyr, was controlled by Linux Foundation, and having our experience with Linux kernel, we decided that for the productivity of the devices, GPL license is not always convenient or interesting, so we have developed it with Apache 2 license. A significant difference from the operating system of the similar class is that from the very beginning we planned to have a complex resolution concerning only the Chateau and the kernel. And even in the first version of Zephyr we had the network stack and some other services. Since many of Zephyr experts are also programmers of dry Linux, many of the useful and good practices in Linux development were brought there. For instance, kconfig, and the main instrument of configuration of Zephyr is kconfig. The minimum configuration in which Zephyr can operate is 8 kilobytes, though commonly that is about 32 kilobytes. For instance, into 32 kilobytes we can even install Notre Dame for Bluetooth mesh launched on controllers, Nortec controllers. As to what is of interest in Zephyr, we are maintaining today 6 architectures. Of course, Intel platform, we can do without it, ARC. My colleagues under the project will give you more detailed information. Telsilic, NH2 and RISC-V, the new development. One of the important aspects of Zephyr is Bluetooth stack. Today, I can prove that this is the most advanced open stack for mobile devices today. Low energy stack that is more functional both for controller and host is not known to me. If you know, please tell me about it. In addition to this stack, and this stack is used by Bluetooth SIG as a reference for the developers. So the examples are how the standards are done. For instance, Bluetooth match have been demonstrated at several conferences on the basis of Zephyr. Besides, we also have a functional network stack with support of 802.15.4 with internet support, with Wi-Fi support. So that's what Zephyr nowadays. Another important function. Today you can build Zephyr as an application to use Linux, the so-called POS export. You can launch the entire operation system as the user process of Linux. A few words about the development process of Zephyr. We live on GitHub. We have a very powerful CI, about 5 jobs are launched for each request for 40 minutes. It is processed and many things are checked, unit test and other things are checked. The organization of the project is more or less ordered. Each critical module and area has maintainers, people who are responsible for them, and we also try to have quarterly rhythm of releases. This year we have released the first release by analogy of what is happening in one service, what is happening in Linux. That was Zephyr 11, which we released this spring, and we recommended to the producers of the equipment who are planning to maintain for the security and bug updates for a long period of time, for several years. What else is important? Tests. We have rather good testing in continuous integration. We have a lot of tests, and we have developed and automated several serious test suites for FP and for Bluetooth. About 1,000 or probably 1,200 tests are launched regularly at these systems. As I already said, the project is organized in such a way that it wouldn't belong to any corporation. The board of the project comprises 4 members: Intel, Nordic, NXP. Oticon is one of the well-known producers of hearing aid devices for people with impaired hearing. In addition, members of the project are the so-called silver members, which take part in creation in all the technical solutions, who participate in different committees of the project, and of course there are our colleagues from Synopsys, whom we are glad to see under the project, and the well-known Texas, both IFI and Linara, and together all that group of companies take the important technical solutions in the project. Initially, as to the scenarios where we think this can be used, we started from the simplest, one-core MCU, single-core MCU. That is a typical scenario for the Internet of Things, for smart sensors, but we didn't stop there, and 2 other scenarios, which will be discussed in greater detail by Alexei Brodkin in his presentation, asymmetric and symmetric configuration, multiprocessor configuration. A very interesting case when Zephyr is used as a specialized core. We support OpenAMP, and for that, before we added support of OpenAMP in Zephyr, we added this configuration in some Intel devices such as Herdina 101 and Edison. Another configuration which I would like to mention, Zephyr operating under hypervisor control in a multi-core, powerful multi-core processor. We don't mean only desktop devices, but also IT devices. The Acorn project, which is supported by Zephyr as one of the guest operation system, considers in its strategic plan Zephyr as a so-called safety kernel. The combination of these 2 operation system of Zephyr and Hyper-V might create a so-called safety kernel, making this configuration certifiable under the security standards, and I will give you more detailed information. That is a very important configuration. Another interesting use case, a real-time function, because as you know, real-time Linux is not as simple, and not everyone is using it, but the function of real-time in Zephyr is present and operating, and one of the cores can be dedicated to such functions. More than today, more than 107 supported boards are supported by Zephyr. Not the entire peripherals, but many peripherals are supported. This is one of these boards that I went, and several boards are released under control of Zephyr. For instance, this Multicon company, I can give detailed information about it during the break. It is an interesting device. It is also also quite interesting that despite the fact that this system is young, there are several products that were produced under control. Zephyr OS license is such that the producers shouldn't inform us that they use our software that is mediated, that is presented at exhibitions, or when they ask us for help when something has failed. And we have a list of devices. For instance, I have never seen how it is used. If you have your personal deer, for instance, reindeer, you can put a reindeer tracker, and the toothbrush is also kind of important. I have bought it to my daughter. So these are wonderful devices used by Zephyr. And finally, a few words about the dynamics of the project in terms of open source. If we compare Zephyr and similar open source operational systems, most of them are in GitHub, except FreeRTOS. Statistically, by the number of total contributors and commits, activity of the project at the end of July, we rank second in the number of contributors, the people who sent code to the project, and we rank second in the total commits to the project. And ranking first in July, we were in terms of commits to master for the last 30 days. I think then Notch window was opened after we had 1.14 release, and everyone decided to add it quickly. Thus, during 4 years of our existence, Zephyr has acquired a good pace of development. We are probably one of the most dynamic projects in this area, and we are ranking second, and Renatec's RTOS ARM supports embed. They are about 10 years. So our project works quite dynamically. Finally, let us pass to the second part, functional safety. I am not an expert, so just a few words about the situation. Why functional safety is related to Zephyr and why do we need it? Functional safety is a rather old discipline in terms of problematics. That is a rather old field which is related to the safety of the system in respect of the surrounding world. Information security is the safety of the system, and functional safety, if something explodes, people should not be damaged when they are around. The theme that I would like to discuss now is of interest for all open source projects that will think about such problems. Just a few words about functional safety. It is applicable to active physical systems, the systems that operate, and to those systems in which errors might lead to damage for the environment and people, buildings, whatever. And one of the examples of this system is a fire extinguishing system, for instance. As to functional safety, there are two types of failures of the system. We mean the failures of the system which we are discussing. Random failures and systematic failures. Random faults, protection is based only on devices and operators in microcircuit of the memory. If a particle gets there, a bit might be transferred, a real case, whereas systematic faults is the faults in development of the system or its implementation, and thus the systematic problems can be solved only by value-added processing of the entire system. That is a typical case of software bugs due to which several missiles fell. Because there were systematic problems, systematic faults, for instance, overfilling of the integer or the mixed the name of the variable. That is not what happens randomly. And everything that I will tell later is intended for avoiding systematic problems and faults. There are a lot of safety standards. They are quite serious international standards. One of the the largest and commonest standard is MAC standard 61508. Last release was in 2010. In Russia, that standard was adapted from 2015. This version. That is a common standard that is not associated with any subject area. It just discusses the principle of building functional safety systems. From it, standards in production, nuclear energy, railway standards are branching off. At the same time, aeronautic standards were developed to the American, European, and medical. When we considered the standard with which we would like to work in Zephyr, we have selected 61508 as one of the most generic standards. But as was mentioned by Tannenbaum, there are a lot of standards. They are different and they are good. You can change anyone you like, choose anyone you like. This February in Nuremberg at the exhibition Evervoid, my colleagues took that picture, the stand of one of the commercial operational systems, and naturally, this attracted our attention. We'll try to determine whether open source is so bad for functional security as a feature. First, why should we consider safety standards for Zephyr? Why Zephyr needs it? As you already know, Zephyr comprises production equipment, so pragmatically, of course, if their equipment is used in the area of functional safety, that will be good profit and good money, and everyone would be interested. Passing from the pragmatic to the romantic viewpoint, no one has done it in open source. The only example is when the operational system was certified in terms of functional safety. That is an example of RTOS. That is a German company. We took RTOS. They kept API. They certified, closed, and now you can come to them and pay and buy the closed operational system. One copy is about 60,000. Therefore, what we want to do, that's very important. We want to make that certification and to leave that operational system open. So we decided to certify, and from the viewpoint of the functional safety standards, what is safe software. Initially, we had an assumption that there is no guaranteed means of proving that in the software there are no bugs. This technique is physically absent. So the only way to make software which is functionally safe is to make it using correct instruments from the viewpoint of the standards and correct processes, and by especially trained people. The correct process of those who created that standard is a V model. You can understand that this is a model where separately we have the architecture, specification, modules. Many of you probably have come across it at your schools and institutes. Since we mean Zephyr, which already has the problems since it exists, we don't have to produce it in a certified way, but we have to prove that in the process of development of Zephyr, we use these methods that were quite needed, that created the necessary artifacts, so that everything is okay with testing and standards, and that is about 200 kilos of documents to be written. And I'd like to note that the instruments that are used for the development
by the same token, they should be standardized. And so as to open source and safety certification, well, may we and can we be certified? Software per se is not a problem. There are lots of products which are even better in quality than when they're in open source vis-a-vis the closed source. Functional safety requires a specific V model to be used and detailed specification of features and technical specification, comprehensive documentation. What's important is that all the high-level technical requirements and specifications should be traced all the way down to the code. Theoretically, neither code which has got those high-level requirements should not be in the system, and just the reverse. For each high-level one, there should be code. And also, the process of development per se should be standardized. Everything should be known about the committers and those who are certifying, and I mean certification authority is not well familiar with the way open source is developed. We are going to create a standalone branch which we call auditable. I'll tell you about it later on. Major work will be in this branch. It will not be a fork, it will be a branch updating from master Zephyr in a regular way. Also, it's very critical to reduce the number of certified code as much as possible, because each string means a lot of work, a lot of money. One string of certified code is between $150 to $200 with the documentation processes and all that. Very cumbersome documentation, lots of documentation. This process should be automated as well. And it's necessary to trace the information all the way down to the code from the technical requirements. We should automate it by all means. All our fabulous ideas were discussed with the certification authority, and they are not against it. If there are other projects to follow what we did, first they should figure out what's to be done, and then this proof concept should be discussed with the certification authority. Scope of certification. We do not plan to certify now anything but the kernel and basic functions such as logins, file systems, databases for parameters, VFS, properties database, and support of the device model to have functionally safe kernel. The certification of a network stack is something out of question. Titanic efforts, no one would like to do that. And we plan to use only stable API, because after certification, it will be very challenging to change anything whatsoever. As to the branch, auditable branch, in which the development will be done, as I mentioned, Zephyr has got two types of releases, long-term support and conventional release. We'll create this branch from the release of long-term service release, and manually we'll be updating it from the subsequent releases. It's very important that those rigorous development processes necessary for certification will be applied only to this branch. Otherwise, we'll splash the baby together with the water we're bathing him in, like we say. We shouldn't go overboard with this, that's what I mean. One of the very important requirements for certification is to track down all the technical requirements from the high level all the way down to the code. It's a must. It's necessary for them to be a high level and also broken down into subsets of different levels requirements in order for those in order to track down those requirements. First, we should create them and identify Zephyr status. So we had to do it de facto. For that code I've shown you, we put together a list of requirements. Lucky for us, we can identify lots of tests covering those requests. Via this, Zephyr will be indicating the code which is in line with those requirements to be implemented. This work is underway. As to the encryption and just coding, actually, we need code reviews and code standard. Code reviews, this is a very good resource, so it's rather liberal process, but this is not enough for the standard, because for standard, it's necessary to be done by the right guy in the right way, and for global project, which is very important, by the way, it's very important so that if those people are in different points of planet Earth, so they should be a pool of requests put together so that guys from America and Europe could review that. This is the problem in Zephyr when merges come along very rapidly sometimes. And following the standard, the guy who pushes the button should have an idea of consequences for that, for functional safety. And Zephyr will have been working in this on this process. Those who will be responsible for the code, all of them will have to undergo formal training on functional safety. Second implication related to coding or programming is the standard of coding. This 6138 standard doesn't tell us what is that, but this is the MISRA, that standard. It's Motor Industry Software Reliability Association. It was set up by this association. They developed the standard of coding. De facto, it's considered to be a standard for functional safe coding, encoding, and it's necessary to correspond to this standard. There are about 180 different guidelines. Some are mandatory, some are required unless a deviation report duly filed, some are advisory in their nature. But problem is that one copy of standard costs 15,000 GBP, just that is British pounds, and not all the rules just make those who are developing it rejoicing. It's a standard, and just per se we cannot deploy it just like that. We should develop our own standard. We do that on the basis of MISRA-C and jet propulsion, not and JTC standards. It's important for us to analyze what we can support and what we cannot support. We'll have to describe it in the deviation document, which will explain why we cannot comply with this or that rule. And this will be reviewed by the certification authority, and they'll make the final decision. But we have come to some agreements with them on a preliminary basis. All those fabulous standards we developed, we'll have to encrypt them so that patch which is launched for typical requests will contain those checkups of those standards, and would block all the unaudible ones. And actually, we selected lots of those check patches. We did that using Cochinelle instrument. As to quality, Briefly, without quality management system, we cannot do much. It consists of tests, result analysis, coverage, unit tests, module tests, system tests, combinations. This is the prerequisite to follow, no matter what we do. As I mentioned in the beginning, our situation is not bad altogether, but not as good as is required by the functional safety to the utmost. We have been working on that. In conclusion, I'm here to say that we have embarked upon very complex and challenging work, very sophisticated, especially it's very complex for open source projects. We want to leave Zephyr open source. We work with the community and inside Zephyr in creation the rules so that the project will function normally in future as well. We are positive it will be the case. Nobody else had done that before us, but Zephyr, as I've said, speeded up in everything it does, and so we have got lots of chances to accomplish it all in a good way. At Linux-Conference 2020, year after that, I'll be able to tell you that everything came out all right with this project. Thank you very much.
Вопросы?
Questions?
Первый вопрос, пожалуйста.
First question. I have a question about the way you implement hardware as well. I don't mean how, but how do you work with hardware, with different devices, because it's a stumbling block. Oftentimes, and let's say if there is a new task when you should transfer legacy code to new code, how difficult it will be to get onto Zephyr stack. Zephyr supports HAL, by the way, but what's interesting is that we support device tree as well, which is quite advanced. I'll show you the architecture.
Самое начало. Вот.
Here we are.
Значит, у нас поддерживается, как я уже сказал,
as I've said, we support HAL at low levels of API. It's based, and also device management on the left-hand side on the basis of device tree. It's also developed in Zephyr. Well, I cannot tell you in more precise way if I don't know from which HAL you would like to shift here. But it was done before, so it was rather smooth for them to make this transition to Zephyr. No microphone. The answer is of course, but this 170, they were developed, yes. As a minimum, there is 1, 2, or 3 examples of those silicons used for that. There are no abstractions.
Еще вопрос, пожалуйста.
Another question?
Здравствуйте, такой вопросик.
I have a question. You said that on the basis of MISRA-C, you'll develop your own standard, something like that. Will it remain open? You'll publish it? Yes, we'll have to do that because this is the open source project. That is why we cannot use MISRA, because we could announce it. The instrument you will develop, what will it be? I mean, the instruments to check up for compliances, everything will be open. That's super. Thank you. Another question. How about local regulator? Typically, in different countries, there are their own standards, safety standards. We have got our own, as far as I know. in Russian CIS, what will happen to them? Will you support them? I'm not an expert in that, but as far as I know, 61508 is standard for Russia as well, is the state standard, Russian GOST. You can find it at the portal of official governmental documents. I've overlooked something else. One, it's about certification of a device. We should certify all the components. Zephyr could be certified, but if your equipment, your hardware and everything else is not certified, so all your efforts will go down the drain. And this standard, international standard, is accepted by here in Russia, depending on the specificity. You'll see whether it's in compliance with this. In most cases, yes. I have a question. When you only started this project or when it became public, Intel had got their own line of microcontrollers, Quarks. Now it doesn't have it. Maybe Intel is going to digress from this project. It doesn't want it. Now Intel is not going to pull out of the project, as you said, the line of Quarks products. Actually, Intel lost interest to this market, but as to the devices manufactured by Intel, developed by Intel, there are lots of chips, big amount of software. This is one of the directions which is interesting for Intel in Zephyr. Thank you.
Little bit more questions. I see one more hand.
A very general question, rather. Tell us about the weaknesses and disadvantages of the project. When we shouldn't consider Zephyr. If you don't want to be happy and lucky developers, then you might disregard Zephyr. I don't know which disadvantages it might have. I'll put it that way. As the developers, commercial system are very interesting because you can dial this number and get by phone to those guys here. It's not possible, but it's important that for certification we'll designate a special dedicated architecture in charge for certification. This is about accountability, so everybody will know who will be accountable. Apart from the absence of the ability to get in touch by the phone or send an angry email, there are no disadvantages. No microphone. I wanted to recap on Andrei's answer to the question, what's to be done, how it's supported, vendors, manufacturers, or IPs, ARM or ARC company, part of Synopsys or Intel, or systems on crystals, or end manufacturers. They are interested in success of end users because they make money by selling different things to their customers. And I, as part of the ARC Synopsys team, we render support to customers when they come along to us. This regards open source products, non-open source products, or dedicated program when people buy a support program, or just because of interest, because our success is based on our customer success. We should think that those companies will be using that, will be totally abandoned. Of course, if it was done in a makeshift way, of course, their product will not be as popular as strongly promoted product. But even those two guys doing that from scratch in the garage, they could get free of charge support because engineers are interested in success of their product, even if it does not make them richer directly. Yes, that's true. And we see that advice advisory companies, consulting companies come along and exercise commercial support. This is interesting. As to the certification of software, I take it the figures and numbers you've provided for one string of a product is about the kernel of the OS. Did you assess user applications on the basis of OS kernel?
You make a specialized device that is dealing with safety. What is the approximate assessment per line of the code? Do you have the data? Unfortunately, I cannot tell you because applications are different, and the application will implement that safety function, bringing the entire system to the safe condition. We can't give any general information, but all this industry is commercial. The entire safety, because everything costs money. The standards won't be received free of charge, and the tools are quite expensive. For instance, for tracing, for requirement traceability, dozens of thousands of dollars of licenses. I know the approximate cost of commercial hardware that was certified according to TÜV, and I would like to know the contribution of the application of the OS. It is difficult to say, but if we manage, we'll change the disruption for that market. And the last question for half a minute, together with the answer, so that we'll have some 9 minutes to have coffee during the break. I'll try to be brief. Thank you very much. It is very interesting. Judging by the architecture, you have a full-fledged OS which contains everything, but you mentioned that it is mainly oriented for IT devices, small devices. Haven't you thought that it could be used for more powerful applications, desktop applications and mobile devices? It is possible, but probably a reindeer tracker, watch also with the interface. If the speaker asks about LibreOffice on Zephyr, that was not the target audience. We don't have any intention to interfere into Linux activities. We know some products in which graphic libraries are more advanced, but the higher we go up the stack, the more difficult it is, and the lower is the value of Zephyr for us per se, because it can be done simply in the same Linux, and there is no sense of producing a device with an advanced interface for 512 kilobytes where Linux will not be installed because the memory is not so expensive and expensive. Thank you very much once again.